So again, if you'd like to use your colored pencils I have provided on the desk or have your own colored pencils or your own highlighter, feel free to use them. I'll give you a minute to set everything up. Just going to wait till everyone's all set because it's going to get a little tougher now. I don't tell you that to scare you. I tell you that to challenge you. All right, we all highlighted, ready to go. Please stop me if it goes too fast or you just got lost. First thing, I'm going to ask you, can you mark anything on your own? Are there vertical angles or a reflexive side? Because that's really the only thing you can mark on your own. Is there a reflexive angle or side or vertical angles in here that I can mark right now before I look at the givens? That's my first question to you. Is there? Number 19, is there? Where? Got it. RS. I'm just going to mark my diagram. I'll put it in there. Now, we can put it in now, sure. RS congruent to RS. Reflexive. And that gives me a full side. So I'll put my S there. All right, let's go to the givens. Everyone ready? For the givens, I got TR congruent to TS. Are those sides in the triangles I need? Is that a full pair of sides? No, so I'm not going to put an S next to it. All right, I can mark it congruent on my diagram, but they are not part of the triangles I need. All right, the other given, TM congruent to TN. TM congruent to TN. Is that a full pair of sides? Nope, so I'm not going to put an S next to that. So really, the givens don't give me any full pairs of sides or angles. I do have one full pair of sides from the reflexive, so you guys I need your help giving me two other equal quantities up here. Two other pairs of congruents, angles or sides up here. All right, everyone ready here? Do we at least see something before I hit the number? We're all set. I know it's tough, it overlaps. Think about what we did yesterday too, 17, anything you see. What could I do with those two givens to get something? I got this side with that side, this side, and this side. I could subtract to get which two sides congruent. Okay, I'm going to subtract. Everyone agree? Subtract. We're all good to go? All right. Before I subtract, do I have two pairs? The two pairs I'm going to subtract, are they equal to each other already? Yes. Okay, so tell me what I'm going to subtract then. Let's roll. 28. Tell me what I'm going to subtract. TS minus TN is equal to, what is it? Oh, I don't want to put that yet. I'm going to put it to the other pair I'm subtracting. TR minus TM. And that's by subtraction. Things don't change around here. We know right after my subtraction step, I'm going to have my substitution step. To say, Teddy, one more time, which two sides now are congruent? MR congruent to MS, and that gives me a second pair of sides. Perfect. All right, I need one more pair of something, either sides or angles here. Sides or angles. Now, here's a hint. If you don't see anything right now, think about what we did yesterday. There's going to be a lot of that in today's proofs. All right, think about the two main facts we used yesterday. 19. What type of triangle is it? You're correct. It's isosceles. Everyone agree? What did I write something wrong here? Or NS? Sorry, NS. Yes, everyone agree that triangle TRS is isosceles. So we learned yesterday what's across from the congruent sides. Congruent angles. Specifically angle MRS. You can call it TRS if you want. Do not call it angle R. Have more self-respect than that. MRS congruent to, on the other side, NSR. We're good there? And this is what we wrote down yesterday. Everyone ready? In a triangle. Congruent, what did we just prove? Angles are across from congruent sides. And that gives me my pair of angles. And really, there's only one choice here I could use. And what method now would the triangles be congruent by? One out of the 5. 20, what method am I working with? Side, angle, side. Whew. How we feel? Look at all that now. Subtraction, a reflexive in there, and the new isosceles triangle facts. Anything you want to ask there? A little bit tougher, huh? Yes, no, maybe? Tell me, or maybe I'm over-exaggerating it. Yes, no? Okay, good talk. Maybe it'll get tougher now. Again, highlighters, colored pencils, whatever you feel free, you need, whatever you think you need. Did I provide you with anything useful? Let's see. Everyone take a look. Side AE is congruent to side ED. Are those full sides? Yeah, nice. How about that? Carlino giving you a little help there. Those two are congruent and they are full sides. Perfect. What about AB and CD? Are those full sides? No, so can't use it as a full pair of sides. So I'll just leave that blank. So the rest is up to you. Trying to get those overlapping triangles congruent. The rest is up to you to find sides and angles. Do we see anything here before I call on somebody? Just getting it. Calm down, Emma. That's why this number generator's here. You and your girl Meg got to calm down there. All right, because I don't call on you. 14. Addition. Well, I need 2 pairs of equal quantities to add. Okay, there's my second pair. BC, congruent to itself. A little reflexive, and everyone see that I'm going to add that to AB and CD. We're all good there? To get full side AC and BD congruent. Yeah, here we go. AB plus BC equals CD plus AB. Addition. And yep, little substitution like usual. AC congruent to BD. Substitution. That is not even close. All right, well, I need another pair of sides or an angle here. Whew, where is it coming from? I need another pair of sides, another pair of angles. $22, how we doing? R. We pirates, all right. Angle A and angle D congruent. And this is what we used yesterday. What type of triangle is A? What's that top letter? What type of triangle is AED, everybody? It's isosceles, right? And what do we know is across from these congruent sides? Boom, congruent angles, A and D. So in a triangle, congruent angles are across from congruent sides. And that gives you your third pair that you needed. Method why these two triangles are congruent. 7. Yes. AEC, DEB. How are we feeling? Not too bad? Good? These aren't as hard as I make it out to be. Not yet, anyway. Not yet. All right. A little different now. What do I ask in the proof statement? Tell me it's isosceles now. Usually I give that to you. Now I want you to prove it's isosceles. So before we start tackling this proof, what do you know about an isosceles triangle? Okay, so we either have to prove two sides equal up here, or we could do what? Two angles. All right, so if we can get two sides, we're good, or if we can get two angles, we're good. And the only thing I'm going to give you is 3 and 4 are congruent, and that's it. That's all I'm going to give you. So can you get me two angles or two sides congruent based off of just 3 and 4 being congruent? That doesn't seem like I'm giving you much, but... And if anybody wants to argue, I'll let you know ABD and AC... Was that F or E? E are straight lines, okay? In case anybody wants to start that argument. Got to go somewhere, right? If 3 and 4 are congruent. Whew. Where are we going from here? Any idea? Oh, I marked, also here's a little hint. I marked angle 1 and 2 particularly for you to use them. All right, I didn't mark this angle up here anything with a number because I don't want you to pay attention to that. All right, so anything you can tell me about 1, 2, 3, 4, 27, anything? Keep going. So it makes them what? So 1 and 3 are angle 1 and angle 3 are supplementary. Is that it? Okay, 2 and 4, angle 2 and angle 4 are supplementary. And what's my reason here? Linear pairs are supplementary. Why does that really matter? Well, what do I know about angle 3 and angle 4 from the givens? They're congruent, so anything supplementary to them should also be congruent. So in that case, angle 1, which is supplementary to 3, and angle 4, which is supplementary to 2, are going to be congruent. Anybody remember the theorem? Supplements of, is this the same angle or congruent angles? Darn right. It's like we never left. And now what do I have now? Two congruent angles. Now, if you want to take it an extra step and say the sides across are congruent, that's fine, but I could stop here because why is this triangle going to be isosceles? What do I already have? Two congruent angles, all right? So triangle ABC is isosceles. You don't need to say the sides. Once you have the angles, you're good. And no, we've already had this discussion. We're not going to write definition of isosceles. Why is this triangle isosceles? Because it has two congruent angles in a triangle, imply it's isosceles. That's all I need. Okay, two congruent angles or two congruent sides, if you went that way, in a triangle imply isosceles. Oh, it's been all fun and games till we get to this last one. And I will not be doing any of it with you. Before you, everybody please settle down for 1 second. It says triangle HJM is isosceles, and I've marked the two congruent sides. So that's part of your givens, those two congruent sides. All right, those sides, because it is isosceles, JH and HM are congruent. All right, and take a look. I'm not asking you to prove triangles congruent. I'm asking you to prove a pair of angles, which usually means, well, how's this proof going to end? CPCTC, but you got to prove what first? A pair of triangles. So you may want to find a pair of triangles first before you guys get going. All right, I'll give you 5, 6, 7, 8 minutes, whatever you need to work this out in your group. It's going to happen from time to time. All right, I know honors kids get stumped every once in a while, and that's fine. Remember, you're going to use all your givens. There's no way around this one. Okay, there's no way around it because some of you may have said, I'll get them on this one because that's isosceles. I saw a lot of people say J was congruent to M because in a triangle, congruent angles are across from congruent sides, which is true. Then you saw the equilateral fact, and you knew these two sides were congruent. Well, all three sides are, but in particular, these two right here. And you thought you were done without even using any of the supplementary givens. But there's a problem here. That's not a method. Is that angle in between the two sides? No, and side-side angle is not one of the 5 ways. All right, so right now, these triangles are not congruent. That's why you needed the supplementary fact. All right, these two are supplementary, these two are supplementary. Perfect, because what do I know about HKJ, HKL, this angle right here, and HLK, these two right down here? They're congruent because they're an equilateral triangle. Or you could say in a triangle, congruent angles are across from congruent sides again. All right. And we also have a theorem that says what? Supplements of congruent angles are congruent. So you needed these angles to be congruent before you said that. All right. So just let me write that down quick. Angle HKL is congruent to angle HLK. You can write definition of equilateral triangle. Equilateral triangle implies all congruent angles. Then you could say the ones next to them are congruent. So angle HKJ is congruent to HLM. Then you could have used supplements of congruent angles are congruent. All right. And again, make sure you put angle J and M in there. And then you could have done, let's see, angle, angle, side, probably is the way. Angle, angle, side, followed by CPCTC. All right. Anything else here you wanted to discuss? So again, I'm serious. You're going to use all the givens. All right. Don't think you're sneaky and you're going to get away with not using one. You're going to always use all the givens. Anything from you guys before we end it? All right, keep going. Keep going with the proofs tonight. Let's see if I can stump you.